So this concept of double conversion, the way it works is it's AC to DC to UPS, right? DC, AC. So when you charge a battery, because the battery is here, right? If you stick a battery inside a plug to charge it, you're going to blow up the battery because AC runs both ways. So when you charge, this value must be greater than this value. It's like a battery. So therefore, you have to have a DC, UPS, DC, AC. This is kind of the mechanism, right? Now, when we do this, is how does this mechanism work from AC to DC? We'll simply say DC to AC goes as an inverter. But AC to DC is a full bridge rectifier. Okay? How does this full bridge rectifier work? Well, we need to understand what the diode. So we'll start with the diode, then we'll move into a half bridge rectifier, full bridge rectifier, and we'll show you how DC is converted. Okay? So let's get started. Right? The first thing we have to look at is our diode. And our diode looks something like this. Now a diode is what you call an LED, light emitting diode. So this is a diode. And what does a diode do? Right? What does a diode do? A diode simply allows the current to flow in one direction. Current does not flow in this direction. It cannot. So think of it as an arrow. The arrow flows one direction. This is a wall. It cannot. It's hitting a wall. So this here flows in one direction. Okay? So how does this work? Well, this side is our input. This side is our output RL. Okay, and I need to write RL here. Okay, to close this up. And okay, just like this. Okay? So here's our input and our output. So our input is on this side. Our output is on this side. Our input is simply here. Our output is our voltage across our RL. So this would be V of L. And this is our output. Okay? And this, we call this V of source. And we already know, right? We already know how to do this because we've done plenty of these problems. Okay? So our AC input is like what? It's like this. It comes in as a sinusoid, just like that. Okay? In this scenario, current flows here, right? And we'll call this I positive because it's flowing in the positive direction. Okay? So I simply cannot flow here. It's impossible. There's no way it can flow this direction. So it only flows in one direction. What's the resultant output? Well, you have V of L minus V of L and 0. So this is V of S, 0 minus V of S. Same concept. So let's just call this A, B, C, and D. A, B, C, D. So if you do it, it's A, B, C, D. Just like that. The output is only positive. Because when the current runs, it's really looking at the first sign convention. If you look at the first sign convention, it's positive. Generally, the first sign convention, you want to just put first sign convention. It's positive. Okay? So here, positive, it goes around, it's positive, A and C is the output. Okay. What is this? Well, let's redraw this. Okay. So this concept here, where it's positive, is called, current's going forward, is called forward bias. Okay, it's forward bias. Here, it's the opposite direction. So we're going to draw the diode in the opposite direction, just like this. Okay. have our input again. So our input is V of S. Our input is coming in. Yeah, this is horrible drawing. Excuse my drawing. I can do better. Let me try better here. I always end up cutting it short, right? V of S. Okay. My current will flow in this direction. Here, let's call it I negative, and it'll flow into here. It will not flow back. Current does not flow back. Okay? So, what is the output? So, V of L minus V of L0. If I label this A, B, C, D, my output will be what? B and D. Okay? Because my current is now traveling in this direction. The opposite direction gives me the opposite output. Here's B, here's D. Okay? This concept is called reverse bias. It's called reverse bias. Okay. Now, next concept. We're going to combine a little bit of mutual inductance into our diode. Okay? And this concept that we're going to cover looks like this. Okay? So we have, instead of a source, we simply have a transformer. And this transformer, obviously, we're going to close the circuit just like that. And this is V of S. V of S is outputting about 480 volts. Okay? You have an end-to-end drop, and now you have 208 volts here. Okay? 408 to 208, and you have some current. Okay? So your current, obviously, is going to flow in this direction, I. Current comes down this way, I. Is going to go over to the transit. Is going to go over here. It's an ideal transformer, right? It's almost a 2-to-1 ratio. It drops. It goes here. Okay. Now, as it goes here, it's going to be your input. And now, unfortunately, your input is not V of S. Your input is V2. And it comes from the equation V1N1 equals V2N2, where V1 is really your Vs. Okay? So that V2 is now your input into the output. So this is V2 minus V2. And we can just call it here. We can just go ahead and draw this out. Okay? And this is obviously 208 here minus 208 here. But it really doesn't matter. I'm not going to ask you that specific question, but we need to understand what's going on. Okay, the result, it's forward bias. So here it's A, 0, C, 0. This is called, this right here, okay, is called the half wave rectifier. You should be able to draw this circuit in a halfway rectifier into end-to-end drop and design the halfway rectifier, if I ask you. Okay, be prepared to do that on the final exam. Okay, I could probably give you some homework problems on this, some small ones. It's really easy, but you be prepared to do this from the top of your head. If I say halfway rectifier, source, you have a transistor drop, you have a transformer, end-to-end ratio, drop to 208. Then it becomes a half-wave rectifier. Okay? So, the third concept is now we call, since we have a half-wave rectifier, the next one is called a full bridge rectifier. And the full bridge rectifier will now transition from an AC to DC. And this is what a full bridge rectifier looks like. You have a diode, 4 diodes is a bridge. Okay? So let's analyze the full bridge rectifier. And the way we analyze the full bridge rectifier is in 2 parts. Okay? You have 2 parts to it. The first part is called positive half cycle. The second part is negative half cycle. Remember, we just studied the half-wave rectifier here, right? We just looked at the half-wave rectifier. So this is the positive halfway rectifier, right? So what we want to do is understand that concept into here, and how does that work? Okay, so again, this is our V of S, whatever that V of S is. This is obviously our V of S. Okay, and we're going to analyze what you call the positive half cycle. The positive half cycle okay, the positive half cycle is when the current flows in the positive direction, just like our initial forward bias. If you remember our forward bias, right? If you remember the screenshot of forward bias I gave earlier, which is right here, our forward bias, that is our positive half cycle. Well, it's done in one diode, but what we want to do is operate in a full bridge rectifier. Okay, so the full bridge rectifier, as we draw the current is this way. I'm going to call it positive, just to know that it's positive half cycle. And what's going to happen as the current comes down here, you have to be able to trace the flow. Where's the current has to go? Well, the current has to go here first, right? It can't go here, right? There's a wall. It goes here. It can't go here. So then our next step is here. And obviously there's a voltage drop here. Our next step is here. Our next step is here, right? Then it can go back in the cycle if it wants, right? There's no change. Or it can come down here. Okay? So our next step is obviously going to be here. I'm sorry, let's write it here. 6 and then 7. So a current comes in, step 1, can't go here. Step 2, don't memorize it, just work it out. 3, 4, it can go back in, but that's kind of redundant. 5, if it goes back in, it's redundant. 6, 7. We need to draw this out. So our input is V of L. Your output is minus V of L. Just like that. So A, B, C, D. Okay. And so what is our output? I'm sorry, this is not V of L, this is V of S. I apologize for my faux pas here. Positive V of S minus V of S. Okay, that's my input. So this is input in the positive half cycle. Okay. We want our output in our V of L. RL is giving an output, so that's plus. It's a minus V of L, and that's 0. This is 0. And what's going to happen is going to be positive, so current only can come which direction? It's going to come here, I positive. It's going to go down this way, right? And it's going to go around, just like that. Okay? So it's only positive. So here, when this input is positive, this is positive. And when this input is negative, right, it's 0, it's skipping it. So here is your positive. So A and B, you're skipping C, B and D. I'm sorry, A and C, and you're skipping B and D. Okay? So what's the other side of positive? Well, we had forward bias, reverse bias. Now we have positive half cycle, and we have something called a negative half cycle. Probably put the hyphen in the wrong place. You'll have to forgive me. Okay. What's a negative half cycle? Well, now the current is running this way. Right? It's just the opposite. So let's analyze what happens when the current runs this way. Okay. Current goes here. Right? Obviously it's going to, and this is, it's going to jump, go here. It's I of negative. Which way is it going to? Is it go this way? No, there's a wall, so it's going to go this way. 1. Can it go this way? No, it's a wall. 2. Where is it going to go here? 3. And obviously there's a VL drop here. You trace it? 4. Now it can come back around again, fine, but that's not our objective, right? Our objective is that it goes around. Right? So can it come back this way? Yes. But what happens if it goes this way? If it goes this way, it can't come back. If this goes this way, right, it's going to go back out. just like this. Okay, so here is 5. Okay, so again, look at it. It's coming in here, here, here. It can go this way. It can go this way, but it's going to go back out this way. Okay, so that's your positive half cycle. So your current is going to run here, just like that. Okay, so when it's running this way, okay, what's the drop? The drop is going to be what? It's positive. So when this is negative, this drop is positive, and it goes here, just like that. That's how you flip it with a full bridge rectifier. If you were to combine these two together, the positive cycle and the negative cycle, you have a full cycle. And this is your sinusoid, A, B, C, D. But you have a problem. It's not quite DC yet, right? If you combine these two, it's not quite DC. Because it's kind of like a weird halfway, kind of peaking. It's peaking more, but it's not going to go negative, right? You're just ensuring that this is positive cycle. Okay, this is a cycle. So what do we ensure? How do we create that DC? Well, we just do it in one more step. That extra step will require a capacitor. Okay, and you're going to have to really study this for a while, and you really need to spend some time on this. It's not intuitive. It's going to take you some time. Okay, so let's talk about what's going on here. Okay, so I'm going to find my notes real quick. I lost all my notes. This is really a messy video. Here. Anyway, I can just do it on top of my head. Okay, so when we have our full cycle here, what happens? We have our full cycle. A, boom, boom, boom. So it's A, just like this. B, C, D. B, C, D. But we have a capacitor discharge. What a capacitor does, it gets fully charged and it discharges, fully charged and discharges. So when you charge a capacitor, it actually holds voltages. So what the capacitor does, it just simply follows it, but it discharges, then it increases, it discharges, it increases, it discharges, and it increases, and it discharges, just like that. So if I'm going to draw the capacitor, right? Okay, I'm kind of making it really bold, just like that. Okay, this is our VDC. It's kind of wavy, but really, really short wave, almost like a straight line. Now, the greater your capacitor, so for instance, the greater the value of my capacitance is farads, the smoother this line. Okay? The less my capacitance value, which is in farads, the choppier the VDC line. Okay? So you would have to be able to derive this thing, and this is basically your full bridge rectifier with the capacitor, and this is how you go from AC to DC, right? So go ahead and study that, and we will pick up the next lesson.